Okay, so from our example, we figured out that, hey, listen, these two things are insignificant. There's no significant relationship, and I mean it, no statistically significant relationship. Othello's wife is not cheating on him, right? But how about if we measure the strength of this association? And the strength of this association we can measure with this formula called phi. And phi is pretty simple, right? And this is phi here, right? And phi simply just takes the chi-square, which we figured out already, right? And the n, which we were given, and we just take the square root of that, and we can figure out how strong this relationship is, right? We already know that it should not be a very strong relationship, right? So in our example, our chi square was 2.0, and there was a total of n was 25, right? So that's pretty easy, right? So all we got to do is divide 2 by 25, right? And that gives us 0.08. And let's take the square root of that. And that gives us a phi of 0.28. So what does a phi of 0.28 mean, right? So let's clear this out. So our phi is 0.28. And let's take phi to be a probability, right? A probability of strength of relationship, right? So let's take our phi to be a probability. We know that probabilities go from 0 to 1, right? In this particular case, let's say that a phi in the middle of 0.5 indicates a moderate strength relationship, right? And a phi below 0.5 indicates a weak relationship. And from 0.5 to 1 indicates a strong relationship. So our 0.25 indicates that this relationship is weak, which we expected, right? So I just like to end this in this section with chi-square with an understanding that this is simply a test for significance. All of our hypothesis tests in chi has solely just been a test for significance. And the significance is in a null hypothesis and the alternative hypothesis. The alternative hypothesis means there was significance. If we reject the null, if we reject this bad boy here, we're accepting that there was significance. If we accept the null, there was no significance. And I'd like to reiterate something before too. So if we just had p-values, if a p-value, let's say we use a statistical program, and if our p-value was 0.6, and our significance level is 0.5, we would be here again, where we would accept the null hypothesis. For a p-value, significance is when it is greater than 0.05. Okay, sorry. Yep.